So starting with the very first question, they have asked us the diagram shows a car ignition switch and a starter motor. The ignition switch in a circuit is is in a circuit with long thin wire. The starter motor is in a circuit with short thick wire. What is the explanation of the choice of wires? We know that if something is with long and thin wire, it does not need a very big, very large value of current. Whereas if a thicker wire is attached to some point, this means that there would be more resistance. So in order to overcome that, thicker wire is used in that place. So we need to look in the options where they have mentioned that point. I repeat, they have written long and thin wire, which means it's not, there is not going to be a large value of current in that part of the circuit, which means even a long and thin wire would suffice the task whatsoever. Whereas if a thick wire is used somewhere and which is short as well, this means that there is a large value of current. For that, heating effects would be produced. So in order to overcome that, we're using that. Whereas we already know that the resistance is proportional to length and inversely proportional to the area. Okay. So this means if area is large and a length is small, resistance will also be small. Clear? Now, we'll need to look at the interlight. Each circuit needs to contain the same total mass of wire. What is the explanation of the choice of wire? अगर ऐसा होता, we would not have chosen this type of wires. Thick wire heats up more quick. Thicker wires heat up more quickly when the relay switch is on. Okay. Yes, वो heat up होगा. Thin wires have lower resistance. No, they have bigger resistance because area has an inverse relationship with the resistance. The ignition switch carries a smaller current than the starter. Whoa. Yes, this is somehow correct. So the reason we discussed just above. Okay, the current smaller होगा, that's why वहाँ पे thin and thicker wire use हुई है. So what would be the right option? Option number D. Moving on to the next one, we have. Did you get this question?
Yeah.
Then we have the diagram shows a simple circuit. We have two lamps in series, a variable resistor, a motor, and a battery attached to it. Cell to be exact. What happens when the resistance of the variable resistor is increased? So everything is connected in series. This would mean there would be a greater resistance at the in the circuit when the variable resistor would increase. So let's see the options. The lamps are dimmer and the motor rotates more quickly. No. The lamps would be dimmer, but alongside the motor would also move slowly. So we have to look for that option. I don't know. And that's we have. The lamps are dimmer and the motor rotates more quickly. Let's see the rest of the
Why
options,
would
which are
the why would the motor rotate slowly?
because everything is connected in series. Now, so increasing the resistance would decrease the value of current throughout the circuit.
Yeah.
So whatever is
Oh,
connected in
okay, okay.
series would be affected alongside. Now.
Yeah.
Then they have written that lamp has same brightness and same brightness. Both are the wrong things, so we do not need to look for other things. So because whenever a circuit is connected in series, it's always it's going to affect the whole circuit. Now they have given us a diagram shows a simple electrical circuit. Which statement cannot be correct? The current is 2 ampere. No, it's just an ampere. And sorry, we have not given any data. E, V, and I. The EMF is 12 joules. I think so. During the making of the worksheet, I've missed the values, whatever was in the circuit.
Oh.
Because only then we cannot say that the value would be 12 joules anyhow. Let's skip that. Moving on to the next one, the cable to an electric cooker contain a live wire, neutral wire, and earth wire. When the cooker is working correctly, in which wires are the current equal? किन टू वायर्स में करंट इक्वल होता है?
The live and the neutral one?
Yes, because live वायर में करंट n होता है, न्यूट्रल वायर से वापस जाता है, so these are the only two wires जिसके अंदर करंट जो है वो इक्वल होता है. Then we have the manufacturer of an electric heater states that only one heater must be connected to the main wiring through any fuse. The current in the circuit with only one heater is 9 ampere. The fuse rating is 10 ampere. Despite the warning, the second identical heater is added as shown. When the switch is closed, fuse blows. The fuse is replaced with a 20 ampere fuse. What happens when the switch is closed? Okay, let me see. ये पूरी ऑप्शन नहीं है यहाँ पर.
Is it D?
Let's पहले सेट तो कर लेना उसको.
Oh wait, no, it's
कि
not. It's not.
हम उसको we need to bring it smaller so that we can see the whole option. Okay, here we have. Okay, now let's read the options. Where is the pen? Let's check. Give me a second. Let me just see कि यहाँ कहीं पे इसको thin करने की कोई option है. मैं उसमें देख रही हूँ कि whether क्या. The physics presented what happens when the switch is closed. Each heater will only receive half the correct current. Okay. Each heater receives twice the correct current. No, that's obviously no. C option क्या था हमारे पास? The heater wiring connecting the heater to the mains may overheat. Okay. The circuit with only one heater is 9 ampere. They must be connected to main through any fuse. पैरेलल में जब कनेक्ट करेंगे ऑब्वियसली करंट ने तो डिवाइड होना ही होना है उसके अंदर. एंड द फ्यूज टू हीटर्स कनेक्टेड होंगे. ईच हीटर विद ओनली वन हीटर इज 9 एम्पेयर. सो अगर हम टू कनेक्ट करेंगे तो उसकी वैल्यू ने क्या होना है, हाफ तो होना नहीं है. बट उसने कहा है कि व्हेन द सिंगल हीटर इज कनेक्टेड दिस मी तो फ्यूज ब्लो हो जाता है. इफ दैट वाज द केस तो ब्लो नहीं होना चाहिए था, तो ऑप्शन नंबर 1 वुड नॉट बी द राइट ऑप्शन. वुड When the switch each heater receives twice the correct current, no, we cannot say that for sure. The overheating is somehow the right option. The fuse melts when the heaters are switched on. But उसने बोला है कि वो 10 एम्पेयर की रेटिंग पे फ्यूज हो रहा था, but with the 20 एम्पेयर fuse rating there might be overheating only, but otherwise उसके अंदर कोई ऐसा issue नहीं आएगा. So I think so we'll go with the option number C.
Wait, so one heater is 9 amperes. What about the second one?
वही तो उसने यहाँ पे वही चीज मेंशन किया ना कि if one heater is connected 9 ampere was the current and the fuse rating was 10 ampere. Despite the warning, a second identical resistor is added as shown. When the switch is closed, the fuse blows, which means there might be a value of current which was more than 10 ampere which was drawn by the circuit. That's why the fuse blew.
Yeah.
Okay. So they replace it with the fuse which had a greater reading. So अगर उन्होंने एक fuse को replace कर दिया है which had a greater reading, this means this fuse would save the circuit somehow. So up when the switch would be closed, only the wires will get heated because the current is flowing across the circuit. Nothing else would happen to the circuit.
But why is it C?
उन्होंने ये बोला उसमें बस यही है ना सेफेस्ट ऑप्शन हमारे पास यही है द सर्किट वाइंडिंग्स may gets overheated only. Nothing else would happen. क्योंकि the fuse melts when the heaters are switched on, तो हमने already fuse को switch ही इसलिए किया था so that the circuit would not blow. The fuse must not blow.
Okay.
Then comes the electromagnetic induction questions that you were asking for. A coil is rotating in a magnetic field. The coil is connected to an oscilloscope. The diagram shows a trace on the screen of the oscilloscope. The coil now speeds up and rotates twice as fast. Which diagram is a new trace? Obviously, option number C and D would not be the right option. We'll choose either from option number A or option number B. Clearly, उसने बोला है कि now it speeds up and rotates twice as much. So out of option number A and B, which one would you choose?
A.
More EMF हमारे पास क्रिएट हो रहा है. So उसका peaks क्या होंगे? वो bigger होंगे then or of the same value ही रहेंगे. Now the EMF is more. Because always remember, whenever we're discussing about the oscilloscope, along x-axis there is time and along y-axis there is voltage given. So if the rotation is twice as fast than before, then the value of EMF must be larger than that of before. So option number B would be the right option. Do you get it?
Yeah.
Okay. Then we have लॉन्ग ट्रांसमिशन वायर्स के अंदर कौन सा ट्रांसफार्मर अटैच्ड होता है? स्टेप अप और स्टेप डाउन?
Step up.
Good. So that the voltage would be greater and the current would be least and heating effects क्या हो? Minimum हो. Then question is, a teacher asks, uses the circuit shown, identical lamps X and Y are connected to a low voltage AC power supply by high resistance transmission wire. Both lamps are switched on. Lamp X is then switched off. Lamp Y stays switched on. What happens to the voltage and what happens to the power supply to the lamp? Voltage supply to the lamp Y. X को अब उसने close कर दिया है. All of the voltage would be given to the O and power supplied to the lamp Y. Both would increase when X would be switched off. Because now there's only one lamp attached to the circuit. Then two.
Voltage and power, they're like directly proportional to each other,
Yes,
right?
P is equals to VR.
Yeah.
So if the voltage would increase, so does the power supply. Then we have a car as a battery. When the car, okay, we have AC supply, we have battery. Acha ji. A car supplies a current in one direction, a current in the opposite direction recharges the battery. So opposite direction, which means diode की direction opposite होनी चाहिए. सो सी एंड डी तो होगा नहीं, बिकॉज पैरेलल में अटैच करने का डायोड का कोई रीजन नहीं होता, बिकॉज डायोड is connected to parallel. If anything, which is playing an important role in a circuit, it is not connected in parallel, because when parallel के अंदर circuit would work anyway if anything is not right, even अगर डायोड सी वो जो है is connected in the right direction or not. So C and D के अंदर हम जाएंगे नहीं. Would choose from A and B. Now it has given us a hint that in the opposite direction the वो recharges क्या कहते हैं बैटरी जो है वो रिचार्ज होती है. सो डायोड मस्ट बी कनेक्टेड इन ऑपोजिट डायरेक्शन टू द बैटरी. तो बैटरी के साथ ऑपोजिट डायरेक्शन में सिर्फ ऑप्शन नंबर ए में कनेक्टेड है. सो ए वुड बी द राइट ऑप्शन. बिकॉज
Wait, can you
अब AC
explain why it's not C
हाँ,
and
आई एम
D?
गोइंग टू दैट. सी एंड डी में तो पैरेलल है ना, जिस तरह फ्यूज को हम कभी पैरेलल में अटैच नहीं करते, क्योंकि इवन इफ द करंट इज हाई वैल्यू का करंट पास थ्रू होता भी है सर्किट से, तो भी फ्यूज वुड नॉट डू एनीथिंग. बिकॉज पैरेलल की एक प्रॉपर्टी होती है कि द सर्किट वुड कीप वर्किंग if any malfunction has occurred to.
Okay.
सेम इन द केस, तो अगर हम डायोड को जो है कनेक्ट करते हैं इन एनी वे, डायोड की कोई परफॉर्मेंस नहीं होगी अगेंस्ट दैट, बिकॉज उस सर्किट के पास पाथ है कि वो इस डायोड को बाईपास करके इट वुड डायरेक्टली गो टू द बैटरी. सो अब in order for diode to work, it should be connected in the right direction. So this is the correct path in which the circuit would go through. अगर उसका सर्किट, because if you remember, हमने डायोड्स के जो है वो ग्राफ्स पढ़े हुए थे. डायोड किस तरह काम करता है हमारे पास. जब सिंगल डायोड होता है हमारे पास आउटपुट आती है, नेगेटिव साइकिल के ऊपर कुछ नहीं आता, देन आउटपुट आती है नेगेटिव साइकिल्स पे कुछ नहीं आता. इन ऑर्डर टू ओवरकम हमने फिर इसके लिए ब्रिज सर्किट्स जो थे वो डिजाइन किए थे. एंड ब्रिज सर्किट क्या करते हैं, at one time two diodes are working. तो हमारे पास आउटपुट क्या आती है, what would be the output? It would go something like this. Input क्या होगा,
Yeah.
this would be our input, and ये पॉजिटिव साइकिल होगा, ये नेगेटिव साइकिल होगा, ये हमारा इनपुट होगा, ये हमारे पास वोल्टेज होगा, ये हमारे पास टाइम पीरियड होगा, and this would be the output. ये ब्रिज सर्किट के अगेंस्ट आती है डायोड के. At one time two diodes conduct. Then उसने this is an easy which does not represent a power source. कौन सा नहीं कर रहा.
Power
There is only one
source?
option. Without a question, voltmeter is not a
B?
power source.
Yeah.
Astaghfirullah.
I
You
said
said
B.
A, na? You said A.
No,
I
I
heard
said
that. Then we have the resistor of different resistors are connected to a power supply in either a parallel circuit or a series circuit. Which statement is correct? The current is the same in all the resistor connected in parallel. Current same होता है, voltage same होती है parallel में.
voltage.
Yes, so option number A is incorrect. The current is same in all resistors connected in series. Yes. The voltage across each resistor is different. Parallel में नहीं होती different.
Yes.
The voltage across each
We
resistor
just-
is same. No. Leaving us with only one option, which is B. You were saying?
Nothing.
Then again, without even getting the values, which would show the greatest reading on the emitter?
A.
And why is
No.
that? Because it's a Oh, yes, A.
Oh. Yeah, that's
Because
what I
it's
meant.
in parallel में astaghfirullah. Parallel resistance जो होती है, that's always the minimum resistance, and the value of parallel resistance is always less than the individual resistor. यानी इस circuit की जो maximum value होगी, it would be less than 2 ohms. ठीक है?
Wait. Oh, so A has the smallest resistance.
Yes, and why is that? Because all of the resistors are connected in parallel. And when the resistors are
Yeah.
connected in parallel, the total resistance value is always less than the इंडिविजुअल रेजिस्टेंस, यानी इंडिविजुअल रेजिस्टर इज मिनिमम हमारे पास 2 ओम है, उससे भी लेस की वैल्यू होगी हमारे पास पैरेलल के अंदर.
Mm-hmm.
Moving on to the next one, a hot plate on an electric cooker contains 2 identical resistors. The switch has 3 positions. 2 resistors are connected in series to the main supply. 2 resistors are connected to the parallel in the main supply. Just one resistor is connected to the main supply. अब सबसे ज्यादा मिनिमम रेजिस्टेंस किस में होगी? पोजीशन 2 में. उससे थोड़ी सी ज्यादा किस में होगी? पोजीशन 3 में. और सबसे ज्यादा किस में होगी? पोजीशन 1 में. So let's see which will be the right option. पहला उन्होंने बोला हुआ है
D.
लोएस्ट पावर किस में हो रही है हमारे पास?
Oh, 2.
Voltage and resistance are, उन्होंने कहा मीडियम पावर किस में होगी? 3 में. एंड हाईएस्ट पावर किस में होगी? 2 में.
1.
2 में हाईएस्ट पावर होगी ना?
Really? But you just said that
उसमें पैरेलल
the ones that
रेजिस्टेंस
are
लगी हुई है ना, तो उसकी पैरेलल रेजिस्टेंस में लो वैल्यू ऑफ रेजिस्टेंस होगी तो करंट उसमें सबसे ज्यादा होगा ना.
Oh, yeah.
So which should be the right option? Option number B. Medium in 3, highest in 2, and minimum in 1. So option number B. I repeat,
Okay.
as it's connected in parallel, which means high current इसके अंदर होगा. इसमें mediocre होगा because only one resistor is connected. और इसमें least current होगा because the resistors are connected in series. I can even show you by putting the values. Let's say the resistors are 2 ohms each. ठीक है? What would be, and the voltage is 12 volt and resistor is 2 ohms each. तो parallel series में total resistance कितना होगा? 4 ohms, and the current would be 12 divided by 4, 3 amperes. Now see 1 by 2, which means 0.5 होगा, because 1 by 2 plus 1 by 2 is equals to 2 by 2, which is equals to 1. So our total would be equals to 1. So अब इसका जब resistance current निकालेंगे, I is equals to V over R. V is 12 volt and I is equals to R is equals to 1. So the current would be 12 ohms. Sorry, 12 amperes. Now let's go for the last one. Only one resistor is connected, which means the resistance would be 2 ohms. Because we already discussed that each resistor has a value of 2 ohms. उन्होंने identical resistor बोला हुआ. ठीक है, हमने सपोज कर लिया, लेट्स दीज आर द वैल्यूज एंड मेन पावर सप्लाई की वैल्यू 12 वोल्ट है, हमने सपोज किया और उसके रिस्पेक्ट से हमने करंट फाइंड आउट कर लिया. अब जो लास्ट 3 ऑप्शन है उसके अंदर हमारे पास जो वैल्यू आ रही है वो कितनी आ रही है? रेजिस्टेंस की 2, तो वैल्यू वुड बी 6 एम्पेयर. अब P इज इक्वल्स टू VI में पुट कर लेते हैं. पहली वाली ऑप्शन में P इज इक्वल्स टू VI करें तो 12 into 3 would be equals to 36, I guess, for position 1. For position 2, voltage is 12 and the current came out to be 12 again. So I guess ये 144 ampere हो जाएगा, sorry 144 watts हो जाएगा. And P3 position के अंदर voltage is again 12 and the current is क्या निकला था हमारे पास? 6 ampere.
6.
So whatever the value would be, but it would be less than this one. So maximum power किस में आ रही है? Position 2 के अंदर. Minimum power किस में आ रही है? Position 1 के अंदर. और मैंने सारा शो भी कर दिया वर्किंग करके. I hope you get it now.
Yeah, I know.
Now अब इतनी सारी वो करने वो क्वेश्चन अब anyhow read करो, मैं रेज नहीं करा cause you might need the copy. Main circuit, electric circuit is fitted with a circuit breaker rather than a fuse. Where is the circuit breaker connected? Without a question, circuit breakers कहाँ पे connect होते हैं?
Live wire.
Always live wire, which means we are going to look for option number A and B. When the current is too large, the thin wire would melt. where the circuit breaker connected, what happens when the circuit is too large? Switch would open. A thin wire, वो fuse के केस में मेल्ट होती है, circuit breaker के केस में मेल्ट नहीं होती. So option number B would be the right option. उसने first वाले में जो option दिया है ना, a thin wire is melted when a large current is passed through it, वो fuse के केस में होता है, not in the circuit breaker. Circuit breaker के केस में electromagnetic switch जो है वो pulled off कर देता है total circuit.
Yeah.
Then transformer है. What is the purpose of the transformer in a diagram? Power transmission, power station से transformer उसको क्या करता है? Step up करता है, voltage को increase करता है, current को down करता है. So we just need to look for that option. So that is only given in option number A and B. Let's read the whole thing. To decrease the current and the potential difference from the potential difference को नहीं decrease करते, तो leave us with only one option. Current को decrease करना and increase the potential difference. So transformer, to step up transformer hota hai, that this is connected in a power station to step up the voltage and step down the value of current. Then a thermistor warms up as the current in it is increases. So when the current would thermistor है, temperature की वजह से जो है उसकी resistance automatically क्या करेगी? Decrease करेगी. So which would be the right option? Voltage and
B.
current. A.
Oh, A, yeah.
Linear
Yeah.
कभी भी नहीं होता. We never go
Yeah.
for linear thing. Then we have. एक second, give me a second.
Oh, and you know,
Hmm.
like in the exam, there was this 4-mark question about how ultrasound works.
वो बबल वाली डायग्राम हमारी बुक में दिया हुआ है कि अल्ट्रासाउंड जो है
Yeah.
on the other side of the object हम डिटेक्टर रखेंगे. If the ultrasound जो receive हो रहे हैं, they all have the same frequency, which means signal is same. But if there is some abnormality in the received signal, that means वहाँ पे कोई issue है.
Oh, okay. I wrote
For
like,
example, if they're asking about see if there is a bubble present inside the tube or not, तो obviously जिस एरिया में बबल होगा वहां पे अल्ट्रासाउंड की वैल्यू जो है वो ज्यादा आएगी as compared to the rest of the area. That's how we would
yeah.
use ultrasound. Even अगर हम वो मेडिकल पर्पसेस के लिए देखते हैं तो फिर वो उसके अंदर वो आ जाता है कि जी रिसीव्ड जो होंगी हमारे पास उससे फिर इमेज डेवलप करते हैं हम लोग रिफ्लेक्टेड वेव से. Okay, I need to raise this.
The paper 6 was like really good. I could solve
Easy होगा
like
ना?
every question. Yeah.
अच्छा, so for first part में couldn't find the razor, पता नहीं वो कहाँ पे है. And they have asked us to find out the value of the current. Let's see what do we have here. We have voltage and उसने cross P find out करने को बोला when they have given the value of resistance of P. So V is I is equals to V over R का formula लगेगा. V is given as 6 volt and R is given as 15. So 6 over 15 would give us a value of 0.4 ampere. Why is that? Because 3, 3 the 6, sorry, 3, 2 the 6 and 3, 5 the 15, so 2 over 5 is 0.4. Now we need to find out the resistance of lamp Q. They have given us the total value of current, which is 0.65, out of which 0.4 is used by the lamp P, which means the remaining current would go to lamp Q. So 0.65 minus 0.4 would give us a value of
0.25.
0.25. We know the value of voltage, which is 6 volt, because parallel में attached है. So R is equals to V over I, which is 6 divided by 0.25. This would give us a value of
24
ohms. The two lamps are now connected in series to the emitter. हमें circuit redraw करना है. So clearly अगर battery attached है तो lamps are connected in series, so the diagram would be redrawn like this. Then we explain why the meter reading is less than 0% when the lamps are cause resistance is increase. Because when lamps are connected in series, the resistance would decrease. Resistance. Okay, so we have a current carrying conductor. It shows a copper wire placed on two copper rods. ये book में diagram भी बनी हुई है. Between the two poles magnet, the crocodile touches the positive terminal of the battery. This causes the copper wire to move. On figure, draw the arrow of direction in the current. How would we draw the direction of current?
We have to use Fleming's left-hand rule.
No.
What?
Current is always from positive to negative. The positive end of the battery is this. तो हमारे पास ये and इधर and this would be the exit point.
But isn't direction of current figured out by Fleming's left-hand rule?
भाई बैटरी अटैच्ड है वो तो अगर इंड्यूस हो रहा होता तो हम फ्लेमिंग्स लेफ्ट हैंड राइट को यूज करते हैं
Oh.
एक्सप्लेन व्हाई द कॉपर वायर मूव्स अलोंग द कॉपर रॉड तो वो हम उसको फिर उसको मैं एक्सप्लेन करेंगे अकॉर्डिंग टू फ्लेमिंग्स लेफ्ट हैंड रूल there would be a force that would act on the copper wire when the magnet कितने मार्क्स का क्वेश्चन है Due to the passage of current across the copper wire, a magnetic field would induce. That magnetic field would interact with the magnetic field of the pole magnets. Due to why isn't it going due to why is it so thick?
Just use the text box.
So due to the passage of current, due to the passage of current across the wire would induce magnetic field which would interact with the magnetic field of the pole magnet and according to Fleming's left hand rule force would be copper बल्कि लिख देते हैं copper wire would experience force perpendicular to it. Then next में क्या बोला हुआ है? Name
I
two
don't
different
understand
devices.
like how Fleming's left-hand rule is related to this part.
First time लेफ्ट हैंड रूल की हेल्प से ही तो हम लोग डायरेक्शन ऑफ फोर्स फाइंड आउट कर सकते हैं.
Yeah, but they're not asking
Also
that.
that's
They're
हाँ
asking...
मैं वही point करने लगा था. Also that's not required in the question, but anyhow Fleming's left hand rule तो apply होना ही होना है. They have asked ना कि what would happen, so that we could explain only on the basis of Fleming's left hand rule.
Oh, okay.
Then motor effects हम लोगों ने दोनों डिस्कस करने थे. So that could be used. लाउडस्पीकर में भी होता है हमारे पास, और किसी भी मोटर इफेक्ट के अंदर कोई भी टू ऑप्शन हम लोग लग सकते हैं. Then what happened? Okay. An electric circuit contains a 7 ohm resistor and a light dependent resistor. And whenever I use this with my Vogue, that's thick. And whenever I'm using my Vogue mouse, it's I don't know why it's thinner.
You should invest on a tablet.
Okay, the next question is उन्होंने हमें बोला हुआ है यहाँ पे कि electric circuit contains a 7 ohm resistor. Here we have a 7 ohm resistor and LDR. They both are connected in series. Electromotive force of the battery is 12 volts. And the oscilloscope is connected across a fixed resistor. Figure 6.2 shows the oscilloscope including the setting of the time base and the Y gain control. Line Q shows the position of the trace on the oscilloscope when the switch is open. This
Wait,
line Q.
Yeah.
So this line Q is the one when the switch is off, and when the switch is open, sorry. And the switch S is closed in the trace and oscilloscope move to the position shown by line P. यहाँ पे उसने डिवीजन शो कर दी है that each box shows 2 volts. ठीक है, along y axis and 50 milliseconds along x axis. Clear?
Okay.
And let me see. अब उन्होंने बोला determine the potential difference across the 7 ohm resistor. So we could see here how many boxes do we count along the y-axis to the position P.
2.
1 and 2. So 1 and 2 कितना हो जाएगा हमारे पास?
4 volts.
4. Yes. 4 volts along y-axis. So our answer would be 700 ohms के cross कितना होगा? 4 volts. Determine the resistance of the LDR. So if out of 12 volt, 4 volt is being utilized by the 7 ohm resistor, rest of the voltage किसके पास जा रहा होगा? LDR पे?
The
So we know the
LDR.
value. So 12 minus 4 would be equals to 8 volts. LDR की voltage हमारे पास आ गया. Resistance, have they mentioned any resistance of LDR? No. And series hai, so we can find the value of current across using these values. I is equals to V over R, and V is 4 volts and R is 700 ohms. So divide करें, क्या आंसर आएगा हमारे पास?
Uh, 1/175.
मतलब उसका पॉइंट्स में वैल्यू बताओ ना, क्या बन रही है?
5.7 times 10 power minus 3.
5.7
times 10 power minus 3.
Okay. Now we have the value of current, and if we go back to the circuit diagram, we could see that they are connected in series, and we know that when something is connected in series, they have the same value of current. So in order to find out the resistance, we'll use the formula R is equals to V over I. What is the value of voltage across LDR? 8 volts, and the value of current came out to be 5.7 into 10 to the power minus 3. So R would be equals to
1400.
Clear?
Mhm.
Then they have said that the intensity of the light incident on the LDR gradually increases. State and explain how the trace on the oscilloscope would move. If the LDR value light intensity incident gradually increase, which means the resistance क्या होगी? Decrease, and the total resistance of the circuit would also decrease. So what would happen on the screen?
The current would increase, so
Yes.
uh,
The line would move
it
up
would,
the oscilloscope.
yeah.
The total resistance would decrease. Hence, current would increase and the line would move up the screen. Moving on to the next one. Rectangular coil. अब उन्होंने करंट इसमें शो नहीं किया हुआ. This means this would be considered as a generator. Generator effect हम इसको consider करेंगे. फोर्स उन्होंने शो कर दी है. जनरेटर्स के अंदर कौन सा रूल लगता है? राइट हैंड रूल लगता है. An upward force of size 9.6 into 10 power 10 Newton X on the side AB, this side AB, and explain why there is a force on the side AB. What would be your answer? Due to change of magnetic flux, coil would
I don't understand
experience
this concept.
force. देखो magnetic field यहाँ से move कर रही है from this point to this point, from north to south pole. ठीक है? Whenever a conductor is moved across the magnetic field perpendicular to it, the charges in that conductor experiences some kind of force due to magnetic field. And when the charges experiences that force, that magnetic field force them to move across the conductor. And when that work is done on the charges, work is done on the charges present in the conductor, this is termed as EMF induced. Because EMF हमने कैसे define किया था? Work done per unit charge. So when work is done on the charges present in the conductor by the magnetic field, so this would only occur if the value of the magnetic field is continuously changing across the coil or the wire. ठीक है? So जब भी relative movement होती है between a magnetic field and the conductor, a force is experienced by the charge, which is basically we term as the induced EMF across the conductor. और when that induced EMF is occurred, so हमारे पास क्या flow करता है? करंट फ्लो करता है. सपोज मेरे पास ये कंडक्टर है. ठीक है? I have a number of charges present here. Now, this conductor is moved across the magnetic field perpendicular to it. So this magnetic field would work on this charge and would force us to move across the conductor. And when this charge would move across the conductor, this would induce an EMF because work is done on the charge, which is the definition of EMF. So as long as the magnetic field is changing across the conductor, work is done on the charge and EMF is induced. But as soon as the magnetic field stop changing its direction across the conductor, no EMF is done. Because एक दफा work done हो गया, it doesn't mean it will keep on working.
But how do you know the magnetic field is changing?
मतलब वो तो फिर हम सपोज करते हैं ना कि if we are getting a reading continuously on the voltmeter, this means the EMF is changing. If the meter is not showing any reading, momentarily it moved momentarily and then came back to zero. This means the magnetic field is not changing anymore. Okay. Now, to deal with this question, they have asked us to find out. Now, according to Fleming's right hand rule, magnetic field is in this direction and force is in this direction. If we put our, क्या कहते हैं, according to left hand rule, if we put our finger, magnetic field किसको show करी होती है? हमारी fingers की direction क्या होती है? ऐसे. Let me show the finger wala portion rather than me showing my drawing skills, which obviously would not appreciate.
Yeah.
I know. Let me go back.
But oh wow. Did you draw this?
Obviously not. कॉपी मारा है गूगल से. अच्छा, अब let me put this finger in. If I could rotate it like this. अब force is upward, magnetic field is in this direction. तो current कहाँ से किस तरफ move कर रहा है?
Towards
From
me.
B to A. ठीक है? So according to left hand rule, the current is moving from B to A. This thumb shows the direction of force. This shows the magnetic field. The finger would point in the downward direction. So current would be from B to A. Clear?
Can you show me again?
Yeah. Put your finger, thumb in the direction of force. Your index finger in the direction of magnetic field. Your middle finger would point in the downward direction. That is from B to A.
Oh, okay.
Moving on to next question. They have asked us to find out the moment, and moment का formula क्या होता है? F cross T. Distance उन्होंने हमें 2.5 दे दिया हुआ है and force is mentioned here. So दोनों का हम आपस में क्या कर देंगे? Multiply कर देंगे. 9.6 into 10 to the power minus 3 times 2.5 into 10 to the power minus 2 for centimeter.
It's already in centimeter.
हाँ, तो उसको meters में भी तो लेके जाना है ना. And उन्होंने both sides A, B and C D बोला हुआ है, so we'll multiply the answer with 2.
Wait, why do you multiply by 2?
Because उन्होंने A, B and C D दोनों के cross पूछा हुआ है. So 2 times the moment होगा.
Oh, okay. 4.8 times 10 power minus 4.
Achha, one thing again. Since they have not given us the unit here, we can either go with this one or simply हमारा 0.048 Newton centimeter भी लग सकता है हम लोग. ठीक है? As we do not have the units already mentioned. So the unit convention is only important when the unit is given in the answer.
Okay.
Now, they have asked us the coil in figure 7.1 is a part of direct current motor. State the name of device that connect the coil of a DC motor to the electricity supply. What is that part called? जो outer circuit के साथ connect करता है.
Wait.
Carbon brushes.
Oh.
We have studied that carbon brushes external circuit से connect करता है and rings जो हैं वो coil के साथ attached होते हैं. Rings to the coil and carbon brushes to the external circuit. So if this is the motor, this is the armature, DC है, so हम लोग यहाँ पे split rings लगाएंगे, which are also known as commutator, and this would be our battery. So ये split rings आ गए for DC. These are the carbon brushes for external circuit. This is armature. And split rings are also known as commutator. Moving on to the next part. We have power, we have voltage, current find out करना है. So P is equals to VI and I is equals to P over V, which is 60 divided by 240.
1/4.
0.25. Resistance calculate करनी है, power is equals to I square R होता है. I हमने calculate किया 0.25 square times R is equals to power, which is 60 watts. So R is equals to 60 divided by 0.25 square.
What? Can't you just
Power
use R equals
VI
V
भी use
over
कर लो.
I?
V over R भी कर सकता है.
Oh, okay.
Answer different आ रहा है.
960. Let me check. No, it's the same.
वो बस पावर का आ रहा था ना, तो मैंने उसी फ्लो में उसको यूज कर लिया. डेफिनेटली वी कैन यूज V is equals to I, बट यू हैव सीन के दोनों का आंसर सेम ही आ रहा है. अब उन्होंने बोला है कि the lamp is now unplugged from the main supply and connected in series with two 1.5 cells. अगर two 1.5 cells हैं तो total voltmeter की रीडिंग कितनी शो हो रही होगी?
3.
Yes, because when EMFs are connected in series, वो add up होती है. So can you explain how the resistance of the lamp now differs from the value calculated in A? Obviously, lamps जो है voltage कम है तो resistance भी कम होगी. Resistance would be less. Smaller resistance.
Because smaller voltage.
Yes, as voltage is small. Voltage is less on. When a filament lamp blows, it very often does so immediately after being switched. So suggest why this is case. So due to the high current, जो उसका filament है, it breaks down. Due to current surge, the filament would break or would heat up and break. That is it for the electricity part. Tomorrow we'll do the electromagnetic inductions.